Hello and welcome, I'm your Code Monkey. In this lecture we're going to learn all about structs. These are structures of data that are similar to classes but also a little bit different. Okay, so structs, like I said, are pretty similar to classes in how you define them. You literally just swap class for struct. So over here, for example, let's make a class named player. Right now this is a class, and just by swapping this into struct, yep, now this one is a struct. So that's it, super simple. However, just doing this has some really important implications. The main one is how classes are reference types and structs are value types, which is what we covered in the last lecture. This means that when you use something as a class, like a class parameter, it gets passed in as a reference, whereas with a struct, it gets passed in as a copy. So here we can do a simple quick test, make a player struct and a player class. Then just run this code, just making the usual start function, because over here I'm working in Unity. Let's make a private void test function struct, and another one test function class. Okay, so here is some code. We create a new struct and new class, and we assign a field inside of them to the value 1. Then we have two functions, and in these functions these do the same thing, so they just set that field into 2. And then we do a log. So let's see whether this one keeps the number 1 or whether it keeps the number 2. And yep, like the log says here, the struct keeps the number 1, whereas the class keeps the number 2. Again, that is because struct is a value type, meaning these are passed in as a copy. So over here we are modifying the copy and not the original data. But classes are reference types, so when we modify a class inside a function, it modifies the actual position in memory, the actual original object. So the reference type gets changed, but the value type does not get changed. This difference is really extremely important, so I truly hope you fully understood everything in the previous lecture. If not, go back to it and rewatch it. It is really important so you don't get confused like I did many times before I memorized this. This is one of the main differences between structs and classes, how classes are reference types and structs are value types. In general, structs are mainly used as just data containers meant to organize your data. The simplest example is really just the vector3 type inside of Unity. So we can inspect this one, so let's right click and go to the definition. And yep, over here we do see this is a struct, and it's a struct that pretty much just holds 3 components, so x, y, and z. So rather than having 3 separate fields whenever we want some kind of position, we just make a struct that in itself has these 3 fields. Whenever we have several pieces of data that all of them make up one logical unit, then perhaps consider making that a struct. However, again, remember how it's a value type. For example, in Unity, you cannot even directly modify one of those components. So if I set the position .5 equals something, if I do this, nope, it does not work. Now, technically, this is more related to the fact that this position is actually a property and not a variable. But still, the reason why it's a property is because it actually copies the data and sends it over to the backend of the engine itself. So in Unity, when you need to modify something, you need to assign it to a new vector3. So basically, you need to give it another copy of another piece of data in order to actually modify it. So usually, structs are used in an immutable manner, meaning they never change. Once you create a struct with a certain value, usually you keep it at that value. However, that is not an absolute requirement. It's really just a good convention to follow. For example, the vector3 struct, so let's do a position, define it as something, 10, 21, something. And like this struct inside actually contains the normalized function. And if we do this and then do a debug.log on this position, let's see. Yep, this function does indeed modify the underlying data. So in theory, structs can indeed be mutable, they can change, but in order to avoid confusion, you should probably avoid this as much as possible. You should probably always treat your structs as immutable. Just following that one simple rule will make things much simpler to understand. Now, structs, like classes, they can have fields, they can also have functions, like we saw here to normalize, and they can even have properties. One big difference is how they cannot inherit. I talk about inheritance in more detail in the next lecture, but basically with a class, you can make it inherit another class. So public class, base class, and then public class for some kind of unit class, and this one can extend base class. So this works, this is valid code. But over here on this player struct, if we try extending base class, nope, an error, structs cannot extend classes. The one thing they can do is actually what this error message is telling us. They can indeed implement interfaces. I will also cover interface in detail in a few lectures. Then structs can also have constructors, just like classes. However, in most C# versions, you cannot have a parameterless constructor. So over here, public player, just like this with no parameters. And nope, we have an error. So as you can see, parameterless struct constructor is not available in C# 9. But if you're using another version, this is possible. Instead of defining it yourself, it always has one by default. So up here we can do new player, and yep, this works. So for the constructors, if we define any of them, it has to have some kind of parameter. So usually on the constructor, you add some kind of thing to initialize the actual struct itself. And then one common error with constructors is this one right here, which is all of the elements, all the fields must be fully assigned before control is returned to the caller. So if we define a constructor like this, we must initialize all the fields. So over here, this .a equals a, and yep, now it does work. So every constructor you make has to initialize every single field within that struct. Again, this has to do with difference between value types and reference types. As soon as you define something of struct type, like for example some kind of variable, like a kind of player variable like this, as soon as you define it like this, if you define it like this, it's an error because it is uninitialized. But we can initialize it. We can just use default. This is a keyword that pretty much returns the default of whatever type we have. So if we do it like this, let's see what this says. And yep, the default of a struct is indeed a struct. And then we can even go inside of it. So let's print out the A. And yep, so it creates a struct and initializes the variables, all of them at 0. So that's what default does, initialize everything with a 0 value. However, if we now make this into a class, and if there it is, default value for a class is null, and since it's null, that means it has no object, so we cannot access anything inside of it. Again, goes back to the difference between value types and reference types. Reference types by default are null, whereas value types, they always have some kind of value. So when you make a struct, you can create a new struct like we saw by using the default parameterless constructor, or we can use any custom constructors, or we can just make the struct and over here define any kind of thing, so a equals 2. And yep, this is valid code for initializing a struct. One more important thing about structs is, once again, how they are related to value types and not reference types. So one big difference is how they are stored in the stack instead of the heap. These are two different positions in memory. One is much more efficient than another. I actually have a nice story about this. In my first Steam game, Survivor Squad, for the implementation of the Fog of War, the world basically has a ton of tiny quads on top. Then as the player sees some area, those quads are marked as invisible and they are not rendered. So each of those tiny quads needs a little bit of data in order to know the position and know whether it's visible or not. In the first version of this system, I stored that as a class and it was terribly slow, and then I literally just swapped class for struct and suddenly got a massive speed boost. All because of how structs are very efficiently stored in memory. So in general, use structs to hold different pieces of data together. And in general, you should use them as immutable pieces of data, meaning they should not change, and consider using them when you have some kind of memory performance issues.